Lesson 5.3, Proving Triangle Congruence by SAS. Essential question, can I prove two triangles are congruent by SAS? In this lesson, we're going to find a shortcut to proving triangles are congruent. Remember, congruent triangles if and only if there is a sequence of rigid motions. We have found in the last lesson that we don't have to find this sequence of rigid motions. If we can match every single angle to every single side, we know that a rigid motion will take place. The lesson here is going to even shorten the amount that we have to show by only having to show two pairs of sides and an angle. Let's go ahead and take a look at the theorem. The theorem is called side-angle-side congruence theorem, abbreviated SAS. If two sides in the included angle of one triangle are congruent to two sides in the included angle of a second, then the two triangles are congruent. The proof goes like this. We have to use rigid motion to show that just this piece of information, just the two sides and the angle, is enough to get us to do a mapping. All right, let's go ahead and start right here. We can take a look. We have two sides and we have an angle, and what we're going to want to do is match DA with D. So we're going to use a translation to match these up, and that's what's happening here. They're hooking up here. Okay, the next step is to take this side and this side, and we're going to rotate it so that they're going to match here. Now we have these two angles that are matching, and we have these two sides that are matching, and if we do a reflection, this side will match to this side, this angle will match to this angle, and all of these other sides and other angles that weren't mentioned will come along and get mapped. So our shortcut is called SAS. Okay, before we go any further, let's talk about included angle versus non-included angle. Included angle means it's the angle found between the two sides that you are talking about. So 15 and 12, this is the angle formed by the two sides. This is a non-included angle. The included angle would actually be this, and the non-included means that it's not between the 21 and the 17. All right, let's take a look at a proof where we try to show the triangles are congruent by this shortcut, side, angle, side. We're going to have to show a pair of sides and two pairs of sides and one pair of angle. All right, I'm going to do my work right here. This is just things that I'm thinking about before I actually do the proof. Well, I can see that I have a pair of sides because I have BC congruent to AD, and I can see I have another pair of sides, and that's this one right here, and we usually mark reflexive with a cross, so I know AC is congruent to AC. And now the question is, can I find an angle? Well, I do have these parallel lines, and I know that this angle will be congruent to this angle, so I'm going to write that. Now you can't just say angle C, because angle C, this is angle C as well. So we have to say angle BCA congruent to angle DAC, and that's going to be with this: if two lines are parallel, then alternate interior angles are congruent. All right, so I've been able to find all of this, and you can see that this angle is included between the marked sides. So now I'm ready to do the proof. Okay, step one, the given. BC is congruent to DA, and BC is parallel to AD, and that's the given. Now I want to write this right away because I have a pair of sides. So I like to cross off, as I'm going through the proof, I like to cross off and say I've met my goal there. Okay, now my angle, remember these two angles. So I'm going to write angle, and in my preparatory work, I already have it written down. So all I'm going to do is copy down in my preparatory work, and I'm going to write, this should have been a 2. If two lines are parallel, then alternate interior angles are congruent. Okay. Now this is going to be a pair of angles. I just want to call your attention to, remember, the parallel came from the given. And my end of my theorem is matching my statement right here. I've said angles are congruent, and I've written angles are congruent here. Okay, step 3, I can go ahead and cross this off. My other side in my preparatory work is AC, congruent to AC, and that's going to be reflexive. I'm going to write an S here. So now I know I've met all the requirements, and now I want to get to my proof statement. Triangle ABC is congruent to triangle CDA, and I've met my requirements, the shortcut, and I'm going to say side, angle, side. Now, you don't have to have it in side, angle, side order. As long as all three of these are mentioned before line 4, you're okay. All right, let's go ahead and take a look. This is a proof. So I'm going to want to do a proof, and then I'm going to want to find x and y. Okay, here's my preparatory work. I have side, angle, side, and I can see here that I'm given a pair of sides, and I'm given another pair of sides, and my angle is going to come from here, and these are my vertical angles. So I think I'll be able to get through this proof. All right, step 1, we write AC congruent to CD. Those are with the 1 tick marks. And the BC congruent to CE. Doesn't really matter the order of the letters. That's given. And while I'm doing this, I like to do this. I like to put S so I know I've met my S requirement and my S requirement. And step 2, my hint is the vertical angles. And again, you can't call this angle C. You got to call it ACB. You got to use 3 letters, DCE, and that's because vertical angles are congruent. And I'm going to put my A. Notice I didn't go in side, angle, side order. I just made sure all of them were listed. And now I'm ready for the last statement, and I can say triangle ABC is congruent to triangle DEC, and it's through the shortcut side, angle, side. Now I'm going to actually solve for x and y. Remember, I was told that AC, this thing, is congruent to CD. So I'm going to go ahead and write that. I'm going to write 4y minus 6 is equal to 2x plus 6. And I can't solve for x or y yet. Now I also know that 3y plus 1 is equal to 4x. Okay, so I have what we call simultaneous equations. There's a variety of ways you can solve this. One, you can solve for x and then put x in, or you can do the elimination method where we put x and y on one side and the number on the other side. And I think that's what I'm going to do. I'm going to have 2x on this side. I'm going to put 2x, and then when I subtract 4y, I'm going to have a negative 4y equals, and then I'm going to subtract 6 on both sides, negative 12. So I subtracted 6 to get the negative 12, and I subtracted 4i to get this one. Now over here I'm going to have 4x, and I'm going to bring the y over to this other side, so that's 3y is equal to 1. So now all my x's and my y's are lined up. I want to be able to multiply the top by negative 2. When I multiply the top by negative 2, I'm going to get negative 4x plus 8y equals 24. And then I'm going to have a 4x minus 3y is equal to 1. And then I'm going to add, that goes to 0, so this is 5y is equal to 25, y is equal to 5. Well, if y is equal to 5, that's one of my answers. Y is equal to 5. I've got to figure out my x. So I'm going to use this one right here. So I'm going to put a 5 in here, and that's going to be 15 plus 1 is equal to 4x. So 16 is equal to 4x. X is equal to 4. So now we have x is equal to 4. And a great review of some Algebra 1. All right, in this diagram we have a circle, and what can we conclude about these two triangles? Well, one of the things we can conclude is all of these are congruent to each other because it's a circle, and we know that all points on a circle are the same distance. We also know that these are vertical angles, so we can say that. And now we have our side angle side, so we can say these two triangles congruent. Now be very careful with the order. The angle M's have to be in the same location. It really doesn't matter about the SR and the PT because these are all congruent, and we're going to get the MS and the MQ congruent. All right, another proof. We're going to, it looks to me like in my plan, I like to do some pre-planning. In my plan I can see that there's a reflexive, so I can see my plan will be side angle side. One of the sides is given. They have an angle bisector, so I'm going to be able to get my angle, and then my reflexive will be my side. So let's go ahead and fill this out. So this is my side pair, so I can cross this off. And here's another side pair. That's from the reflexive. Now, right here we have an angle bisector. And when we have an angle bisector, it cuts angles into two. So this is my angle pair. And this comes from definition of angle bisector. Now, once I've met the plan, I can now say the triangles are congruent by the shortcut side angle side. Okay, here's your opportunity. I've given you all the steps. See if you can figure out the reasons, and the answer will be shown in the next slide. And here's the answer. And notice how I go about writing all my pairs here. And I want to make sure I fulfill the shortcut and I have every single one of these pairs shown. And this is the end of the screencast.